this is the lecture number 20 for the chapter integration, and in the last lecture we have completed exercise 10.10. Now in this exercise of 7.11 is based on the properties of definite integral, which we have discussed before the starting of the definite integral. Now in question number 1, integration is 0 to pi by 2 cos square x dx. Now in this, because limit is from 0 to pi by 2, that is from 0 to a, so in place of x we can write pi by 2 minus x, that is a minus x. The property we have used from 0 to a, definite integral fx is equal to 0 to a f a minus x, and this property we have already used. So in place of x we can write pi by 2 minus x. Now cos square 90 minus theta is sin square theta, cos 90 minus theta is sin theta. Now if we add step number 1 and 2, see it very carefully. If you can add step number 1 and 2, you'll get cos square plus sin square, which is equal to 1. So it means now you have to integrate only 1, which is x, and upper limit minus lower limit is pi by 2 minus 0, that is I is equal to pi by 4. So this is the method to do the definite integral by using the property. Now in question number 2 also we have to use the same property from 0 to pi by 2 definite integral, and to integrate 1 upon 1 plus root cot x. First of all, convert into sin and cos, which will become root cos x upon root sin x. It will become root sin x upon root sin x plus root cos x. Using the property, in place of x use pi by 2 minus x. 0 to a limit is, so in place of 0 to a we can write a minus x, that is pi by 2 minus x. So sin 90 minus x, sin 90 minus x, sin 90 minus x. So sin 90 minus x is cos x, sin 90 minus x is cos x, cos 90 minus x sin x. Now if we add step number 1 and 2, see it very carefully. Step number 1 and 2, I plus I 2i. Now if we add these two steps, it will be root sin x plus root cos x upon root sin x plus root cos x. See it very carefully, this, and it will be equal to 1. Cancelled out 1. Integration of 1 is x, and it is upper limit minus lower limit, that is pi by 2 minus 0. So I will be equal to pi by 4. Similarly is the question number 3. Same method is there. I is equal to 0 to pi by 2 sin raised to power 3 by 2x upon sin 3 by 2x plus cos 3 by 2x. So in place of x, root use pi by 2 minus x, pi by 2 minus x, pi by 2 minus x, pi by 2 minus x. See it here. It become cos, it become cos, it become cos. Cos 90 minus x is sin x, sin 90 minus x is cos x, and cos 90 minus x is sin x. Now again add step number 1 and 2 again. So in the numerator we have same, cos raised to power 3 by 2x plus sin 3 by 2x upon cos raised to power 3 by 2x plus sin 3 by 2, cancel out. It will be 1, and you have to integrate only 1. So it is somewhat easy questions. So these properties of definite integral make the question almost very easy. Now in question number 4 is similarly as the question number 3, as 1 as well as 2. So in place of x you write pi by 2 minus x. Using the property 0 to a, in place of x we can write a minus x. So 90 minus x, 90 minus x, 90 minus x. This, it becomes cos, it becomes sin, it becomes cos, it becomes sin. When you add again this step number 1 and step number 2, it will again equal to 1. The numerator and denominator become the same. Again you have to integrate only 1, and its integration is x, and upper limit minus lower limit, it again become pi by 4. Now in question number 9, I is equal to 0 to 2x under root 2 minus x with respect to x. Again if you replace the x by a minus x, that is by 2 minus x, so in place of x 2 minus x, in place of x 2 minus x with respect to x. So in this it becomes 2 minus x root x. Now in this you don't have to add the step number 1 and 2, because by adding these two up we are getting nothing. You're not getting simplified, rather it become difficult. But after using the property, this integration become easy. That is, now you can integrate root x and x root x easily. So it become 2x to the power half, and this into this x raised to the power 3 by 2, which can be easily integrated. in which we can easily integrate it. So x की power half means x की power half plus 1 upon half plus 1, x की power 3 by 2 plus 1 upon x की power upon 3 by 2 plus 1. Just simplify the denominator and using upper limit minus lower limit, upper limit minus lower limit, and simplify as far as possible. Now see it very carefully. 2 की power 3 by 2 means 2 into 2 की power half. 2 की power 5 by 2 means 2 की power 2 into 2 की power half. Simplify as far as possible. Now question number 8 is again very important. I is equal to 0 to pi by 4 log 1 plus 10x. So again you have to use the same property. In place of x you have to write pi by 4 minus x. In place of pi by 2 we have pi by 4. So pi by 4 minus x. Now use the formula here, 10 pi by 4 minus x, 10a minus 10b upon 1 plus 10a 10b, it will be 1 minus 10x upon 1 plus 10x. Rather you must know this formula, 10 pi by 4 minus x is equal to 1 minus 10x upon 1 plus 10x. Add this bracket, it will be 2 upon 1 plus 10x. See it very carefully. If you add these two by taking the LCM, it will be 2 upon 1 plus 10x. Now use the property of log 2 minus log 1 plus 10x. This property of log. Break into two integrals, log 2 integration log 10 1 plus 10x 0 to pi by 4 0 to pi by 4. Rather take log 2 common, take outside the integral. Now see this, it is again whatever from which we have started. This is equal to I. This same, take this to the left hand side, and the integral of 1 is x and upper limit minus lower limit. So it will be I is equal to pi by 8 log 2. So it is a very good question and an important question also. Question number 7, again using the I is equal to 0 to 1, x 1 minus x raised to power n. So in place of x write 1 minus x, in place of x write 1 minus x. We are using again the property from 0 to a, we have to replace x by a minus x. So in place of x write 1 minus x. Simplify it. Now again you don't have to add the first and 2 because rather it will be difficult, but by using the property of this, in place of x 1 minus x, the integration will become somewhat easy. So now you can integrate it x की power n and x की power n plus 1. You can easily integrate this. X raised to power n is x की power n plus 1 upon n plus 1 and x की power n plus 2 upon n plus 2. This. Use upper limit minus lower limit. In place of 1 की power n plus 1 and remaining lower limit will be 0. So 1 upon n plus 1, 1 upon n plus 2. So these are the question based in almost all the question. Property is being used. Which property is being used here? In place of x, you can write a plus x. We have done this property in the starting of this chapter. These properties we have done. See it very carefully again. We are using in most of the question this property, that is 0 to a fx. Then in place of x we can write a minus x, and this property we have used in most of the question, and we have also proved this. Recall this theorem. Okay. Now in question number we have done up to question number 7. Now in question number let us take question number 10. The remaining we'll do after these questions. In question number 10, see the terms very carefully. It is from 0 to pi by 2 log sin x minus log sin 2x with respect to x. So 2 log sin x, and for sin 2x you can write 2 sin x cos x, and using the property of the log, for the product we have log 2 plus log sin x plus log cos x. See it very carefully. And minus sign we have, so it will be negative sign here using the properties of log. Now 2 log sin x minus log sin x will be equal to log sin x. Now break into two integrals. Break into two integral. Log 0 to pi by 2 log sin x, 0 to pi by 2 log 2, 0 to pi by 2 log cos x. Now here use the property same from 0 to pi by 2. So in place of x you can write pi by 2 minus x. Yes. You have to use only in this property because this will be cancelled out with this. So log sin pi by 2 minus x is equal to log cos x. This will be cancelled out with this. Say it very carefully. This. So you have to integrate only 0 to pi by 2 log 2, which can be integrated by taking log 2 outside the integral. That is, you have to integrate only 1. Then upper limit minus lower limit, x upper limit to pi by 2 minus 0, that is minus pi by 2 log 2. You have to integrate. So it is a good question. Now in question number 11, see the limit, it is from pi by 2 to pi by 2. Now whenever we have the limit from minus a to a, we have done the property. If it is an odd function, then its answer is 0, and if it is an even function, then it is equal to twice 0 to a fx. So it is minus pi by 2 and sine square x is a even function, because if you replace x by minus x, you are getting sine square x. I have explained it very well in the starting of the definite integral, that is before the starting of the exercise 7.9. So it is an even function, so I can write I is equal to twice 0 to pi by 2 sine square x. Because if it's an even function, then if the limit is minus a to a, then it is equal to twice 0 to a fx. Twice 0 to a sine square fx is sine square x. Now you can use the property of a minus x, that in place of x you can write pi by 2 minus x. It is a property from 0, indefinitely from 0 to a, then you can write in place of x pi by 2 minus x. So sine 90 minus x is cos x. Now if we add this step number 1 and 2, see it very carefully. Sine square plus cos square, it will be, and it is equal to 1. That is, you have to integrate only 1, whose integration is x, and upper limit minus lower limit. This 2 will be cancelled. When you are adding these first and second, take care of this 2. Say it carefully. Now in question number 12, it is somewhat a longer question than the previous. Now I is equal to 0 to pi, the integration is 0 to pi x upon 1 plus sin x. Now again we have to use the property from 0 to a, because in most of the question we are using the same property. In place of x you can write pi minus x, because in place of pi by 2 we have pi minus x, pi minus x. See it. Sin 180 minus x is sin x. Now when we add these two, the x will be cancelled out. We have only I. In left we will be 2i. I plus I 2i. When we add these two, denominator is same. X will be cancelled out with this x. So it will be only pi. Take pi outside this integral and rationalize 1 plus sin x by multiplying and dividing with 1 minus sin x. So in the numerator we have 1 minus sin x. In the denominator 1 plus sin x into 1 minus sin x will be cos square x. Separate into two integral, 1 upon cos square, sin upon cos square. This is sec square, and this is sec x into tan x. This is sec x into tan x. Sin upon cos tan, 1 upon cos sec. You know the integral of this tan x. You know the integral of this sec x. Integral of sec x tan x is equal to sec x, and integral of sec square is tan x. And integrate and use upper limit minus lower limit. You will get the answer as pi. We'll discuss the remaining in the next lecture. Thank you.